Alrighty everyone, today we're looking at special right triangles. We're starting off with our 45, 45, 90 triangles. That is to say, these are going to be triangles that have three sides, specifically isosceles right triangles, wherein two sides are the same length, and the third side, the hypotenuse, has a specific relationship between the two. Angles, well, we've got our 90-degree angle, a 45-degree angle, and another 45-degree angle, giving us our name of a 45, 45, 90 triangle. Now what's the relationship to the hypotenuse? Well, set the hypotenuse equal to c, and we essentially have the setup for a Pythagorean theorem breakdown. This is also example 1 on this sheet if you'd prefer to look over there. So we have our leg and our hypotenuse. So we can say that based on our Pythagorean theorem, that x squared plus x squared equals c squared, which means then that 2x squared is equal to c squared, or, taking the square root, c is equal to the square root of 2x squared. Now thinking back to how we worked with radicals, we've got this square inside the square root, so we can pull out this square here, such that our c, our hypotenuse, is equal to x times the square root of 2. So the relationship we have, essentially, is that if we know a leg, we multiply it by the square root of 2 to get our hypotenuse. If we know the hypotenuse, we set it equal to x times the square root of 2, it will give us our leg. So, example 1, that's basically the example I just did for you. Example 2, in a 45, 45, 90 triangle, hypotenuse is root 2 times longer than the leg. Hypotenuse is 6 units. What is the length of each leg? So we're always going to draw out our little pictures. We have a 6-unit length. We want to find what our x's are. Well, my first steps, I'm going to set my x root 2, my established relationship for the hypotenuse, is equal to 6. Divide both sides by the square root of 2. X is equal to 6 divided by the square root of 2. We have to rationalize that denominator. So I'm going to multiply it by 1, the special kind of 1 formed by the square root of 2 divided by the square root of 2. Because any number over itself is 1. When you multiply something by 1, it doesn't change anything. It doesn't change the value of the problem. So, x is equal to 6 times the square root of 2 over 2. Simplify, x is equal to 3 times the square root of 2. So each leg of this triangle is 3 times the square root of 2. Hypotenuse is 6. All right. Let's take a look at some practice problems. So, example 1, or exercise 1, we want to find the hypotenuse, but we know the leg of 8. Well, my hypotenuse is going to be my leg times square root of 2. And done. Example 2, we're given the hypotenuse. We want to find the leg. Well, the hypotenuse is always going to be, for a 45, 45, 90 triangle, the leg times square root of 2. So if the leg times square root of 2 is equal to 3 times the square root of 2, then our leg must be equal to 3. Number 4, well, same sort of similar setup. We have our leg that is known. We want our hypotenuse. The orientation is different, but the hypotenuse is still going to be the side that is opposite our 90-degree angle. So my x here, my hypotenuse, is my leg times square root of 2. Number 4, once more, we know the hypotenuse, in this case 18. So x root 2 is equal to 18. Divide both sides by the square root of 2. X is equal to 18 over square root of 2. We want to rationalize that denominator. so multiply it by that special kind of 1. X is equal to 18 root 2 over 2, which simplifies down to x equals 9 root 2. Number 5, just like in number 4, we know the hypotenuse of 16. So x root 2 is equal to 16. Divide both sides by square root of 2. We get 16 over square root of 2, which we want to rationalize. So we're going to multiply by that special kind of 1. X is equal to 16 root 2 over 2, which simplifies down to 8 over 2. Last one. We have the hypotenuse as known. The hypotenuse in a 45, 45, 90 triangle is always going to be whatever the leg is times square root of 2. Which means then that 24 is our x, which means x equals 24. And that is our setup. Knowing this relationship of our 45, 45, 90 triangle makes things much quicker. If you need it written out as a ratio, well, it's the leg to the leg to the hypotenuse. All right, let's take a look at some quick little word problems. Number 7, in a 45, 45, 90 triangle, the hypotenuse length of 12, find the leg length. All right, now I don't really need to do it, but I'm going to draw a picture anyway for your benefit. You should always get in the habit of drawing pictures when you need them. We need to have the hypotenuse of 12. Got a pair of x's. So x times square root of 2, which is our hypotenuse ratio, is equal to 12, which means that x is equal to 12 over square root of 2, which is going to rationalize, which will give us x is equal to 12 times the square root of 2 over 2, which simplifies down into 6 times the square root of 2. So 6 root 2 for number 7. Number 8, determine the length of a leg of a 45, 45 degree, 45, 45, 90 triangle, hypotenuse of 12 inches. Well, sorry, of 24 inches. English, 25 inches. Well, once more, we're going to set up our equation, draw a little picture. Hypotenuse is 25, got our x. So x root 2 is equal to 25. X is equal to, getting ahead of myself, 25 over square root of 2, which we're going to rationalize. So x is equal to 25 times square root of 2 over 2. Now I'm going to leave it just like this, but if you want to, I suppose you could break it down into, 12.5 times square root of 2. I just don't like having radicals and decimals with each other. Number 9, find the length of the hypotenuse with a leg of 14 centimeters. All right, well, fairly simple setup. Triangle. My leg is 14 centimeters. My hypotenuse is going to be the leg times the square root of 2. And that's that. That is the end of our notes in under 10 minutes.